Hey everyone, welcome back. Today we are going to talk about angles. We are going to, in this lesson, learn how to measure and classify angles. But first we need to learn what angles are. Now here's a little bit of a review that we're going to go over later. Let's get right into talking about angles first. An angle is two different rays with the same endpoint. So here is a ray. Here is a different ray with the same endpoint, and that forms an angle. The sides are the two rays. So here's a side, and here's a side. The vertex is the common endpoint. So this right here is called the vertex. Okay, now what's inside of this angle? This is called the interior of the angle, which means everything out here is called the exterior of the angle. Okay, now let's draw another angle and let's put some points with names on it. So here we'll call this point A, we'll call this point B, and point C. Okay, now let's talk about how to name this angle. So I could call this angle, see there's an angle symbol, angle ABC. I could also call it angle CBA. But notice both times the vertex is in the middle. We have to name it with the vertex in the middle. I could actually just call it angle B. Okay, so I can name it by 3 points with the vertex in the middle, or I can just name it by the vertex as long as there's only one angle in the picture. And we'll talk about what it might look like if there's more than one angle when we get to the back page. Okay, so 3 letters with the vertex in the middle, or just the vertex, but make sure you have an angle symbol there. Okay, name 3 angles in this diagram. So I see angle WXY. X is the vertex. W and Y are on the sides. I also see angle ZXY. Now, of course, I can turn these names around. YXW, YXZ, but I have to put X in the middle because that's the vertex. Okay, so that's the top angle and then the bottom angle, but then I've also got this outside angle, WXZ, angle WXZ, or angle ZXW. Those are 3 different angles within that one picture. But notice this is a situation where I've got more than one angle within one diagram. You should not name any of these angles angle X because all 3 angles have X as their vertex. So if I just said angle X, who knows if I'm talking about this top angle, this bottom angle, or this outer angle. So when I have multiple angles within a diagram, I cannot name it just by the vertex. I have to go 3 letters with the vertex in the middle. Okay, now let's talk about classifying angles. There are 4 different classifications we are going to talk about. The first one is acute. An acute angle, that's all we've even looked at so far is acute angles. Acute angles can look like this. They are angles whose measure, and we'll call that measure X, are between 0 and 90. So greater than 0 degrees, but less than 90 degrees. Not equal to, not greater than or equal to, or less than or equal to, but greater than 0 and less than 90. A right angle is when X, the angle measure, is exactly 90 degrees. Okay, so that would look like this. And you'll often see a symbol, just a little square inside the angle there. That little square tells you this is a right angle. It is 90 degrees. An obtuse angle looks like this. It is bigger than 90 degrees. So that angle measure x is greater than 90 degrees, but it is less than 180 degrees. When it gets to exactly 180 degrees, that is called a straight angle. So a straight angle looks like that, 180 degrees. Okay? Now, what we actually end up with here is a line. It's a pair of opposite rays with the same endpoint that go exactly the opposite direction. So I'll even make a note of that this is a pair of opposite rays, which means this 180 degree angle, this straight angle, forms a line. Okay, let's talk about measuring angles. So this right here, this is a tool called a protractor. So I've got a picture of one on the notes here. Okay, you may have one. It's just usually a plastic tool. But we'll just use this picture. So we are going to measure 4 different angles here. So angle KHJ. Okay, so that means H is the vertex. And on the sides you see a K and a J. Okay, so this is the angle we are looking at. Now, there are 2 different sets of numbers, 10, 20, 30, 40, and then 180, 170, 160, 150. So what we have to look at is what type of angle this is. Okay? And it even says, classify the angle. So let's do that first. That angle is not as big as 90 degrees. That is an acute angle. So we actually have done this second part. We've classified it. Okay? Now that we know it's acute, that means we are using this smaller set of numbers between 0 and 90. Okay, so I'm going to start here and just work my way around this protractor until I get to the second side. So I've got 10 degrees, 20 degrees, 30, 40, 50 degrees, but not 60. It looks like it stops halfway between right there at 55 degrees. So it is a 55 degree angle. Okay, next is angle GHK. So it's got G on a side, H as a vertex, K on the other side. So I'm looking at this angle, GHK. Now that angle is bigger than 90 degrees, so I know it's obtuse. So I'm going to be giving it a measure that is between 90 and 180. Okay, so I can still count the same way, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, not to 130. Looks like it's right there at 125. So this is 125 degrees. Angle GHJ. Okay, so it's got G as a side, H as a vertex, J is on the other side, and that opens all the way around this protractor. That is a straight line, so it is a straight angle. So classify the angle, it is a straight angle, which means its measure is 180 degrees. Angle GHL. That looks like it's right there at 90. So it goes from 0 to 90. That is a right angle. It is 90 degrees. Okay? Name all the angles in the diagram. I see 3 angles. I see one here. I see another one here. And then I see a big angle right here. Okay, so I've got angle PQ, Q is the vertex, R. Angle PQR. Angle PQR. I see angle SQR. Angle SQR. And I see on the outside, there's angle PQS. Angle PQS. Notice every time Q, the vertex, is in the middle. And I used an angle symbol for every one. I could turn these around. RQP, RQS, SQP. Okay, so I'd be allowed to put those names backwards, but I still have to have Q, the vertex, in the middle. Draw a pair of opposite rays. So here is a ray. Okay, we'll call it ray AB. Here's an opposite ray. We'll call it ray AC. So ray AB and ray AC are opposite rays. What type of angle do these rays form? So they form a straight line, which is called a straight angle. All right, with that, let's go back to the beginning of the notes where we're going to do some review. Segment AB bisects segment CD. Okay, so let's draw a picture of that. So I've got segment AB bisecting segment CD. So let's call this one CD. AB is going to bisect it. So I'm going to put a point right there and call that the midpoint, which means this is congruent to this. And say this is segment AB, it is bisecting segment CD. Okay? And it does that bisecting at point E. So this right here is point E. If CE is 2 1/4 inches, how long is CD? Well, if CE is 2 1/4 inches, then DE is also 2 1/4 inches. Okay? So if I add those together, 2 1/4 plus 2 1/4, 2 plus 2 is going to give me 4. 1/4 plus 1/4 is 2/4. So I get 4 1/2. And that's 4 1/2 inches. Point M is the midpoint of segment XY. That tells me that these two sides of it are congruent. XM and YM are congruent. Find the length of XM. Okay, since these two are congruent segments, I know their lengths are equal. So 2x plus 7 is equal to 8x minus 23. I can subtract 2x from both sides and add 23 to both sides. And I get 30 equals 6x. And divide by 6, and I get x equals 5. Now what I want is the length of segment XM. So the length of XM is 2x plus 7, so that's 2 times 5 plus 7. That's 10 plus 7. That should say XM equals 10 plus 7 is 17, so the length of segment XM is 17. Find the midpoint given two endpoints. So the midpoint is x plus x, the average of the x's. So x plus x divided by 2. Then the average of the y's, negative 6 plus 0 divided by 2. So that's 2 plus negative 8, negative 6 over 2. Negative 6 plus 0 is negative 6 over 2. So the midpoint is negative 3, negative 3. Okay? This time we are given the midpoint and one endpoint. Okay, so the midpoint is found by doing the average of the x's, but I don't know one of the endpoints. So this h, we're just going to call that the coordinates x, y. So when I add my x's and divide by 2, I get 4 plus h, or I'm sorry, 4 plus x over 2. Okay, when I use the wrong point there. I used the midpoint. I should be using the end point. So I'm using these two endpoints. So that should be 5 plus x over 2. Okay, now the endpoints y values. 3 plus y over 2. And the average of the x's and the average of the y's gives me the midpoint, which is 4, negative 1. So from there, I get two different equations. 5 plus x over 2 gives me the midpoint's x coordinate, 4. And 3 plus y over 2 gives me the midpoint's y coordinate, negative 1. Multiply both sides by 2. 5 plus x equals 8. Subtract 5. X equals 3. Okay, multiply both sides by 2. 3 plus y equals negative 2. Subtract 3. Negative 2 minus 3 is negative 5. Okay, endpoint h is 3, negative 5. And last, find the distance between these 2 points. Okay, so to find the distance, we are going to use the distance formula. Okay, so the distance formula, d equals x minus x squared, 7 minus negative 3 squared, plus y minus y squared, 2 minus 8 squared, all under a radical. 7 minus negative 3, that's 7 plus 3, is 10 squared. 2 minus 8 is negative 6 squared. 10 squared is 100. Negative 6 squared is 36. So we get the square root of 136. Let's do a factor tree for that. 136. Okay, so 136, I can try all different kinds of numbers. I know it's even, so let's just use the most obvious. 136 divided by 2 is 68. 68 times 2. 68 is also even. You can divide by 2 again. 34 times 2, and there's a pair. I'm going to circle that. 34 is even. Divided by 2 is 17. And it looks like I'm down to only prime numbers. The only pair I find is a pair of 2's. What stays inside are these 2 leftover primes, 17 times 2. So it's 2 times the square root of 34.